Hello everyone, welcome again in Eng-Man YouTube channel. So in this video or series of videos, we are going to learn about CO2 sequestration modeling. It's 3D simulation using CMG software. Okay, so I'm going to use a case from CMG itself. Hopefully we can learn many things from this exercise. Okay, so we are now inside the builder. By the way, we will run the simulation using GEM. So click on New, Simulator GEM, Working Unit, for example, International Standard, Porosity, Single Porosity. And let's say we are going to start the simulation from the year 2000, 1st January 2000. Click on OK. So it's just to make sure that we already select the setting that we wanted. So click on OK. And then we will import the geological model inside the CMG, and we are going to import the rescue file. The rescue file can be created from geological software like Petrel, all right? And then we just need to import it here. So click on File and import from another file and rescue or rescue.ml model. Okay, click on this one. And this is the location of my rescue model, the geological model, delivered or transferred via this file. The extension is .bin. So just touch that one and then click on open. All right, let's wait for a while. Okay, so this is the like notification, rescue file version 37. It's just to make sure the version which created the rescue. It's not very important, it's not very crucial for our simulation, so let's just click on open. And here, import global grid, yes, select this one. And here, inactive cell options, this is to, when we created the geological model, some cells are actually inactive. And those cells, those inactive cells, are not useful at all in the dynamic simulation. So yeah, in many cases, we want to hide that cells, okay? But in this case, the rescue file that we will use like this. All of these options are already inactive, so it helps us. But in many cases, you need to select either no action. If you select no action, then all the cells will be transferred to this GEM, to the CMG or to your simulation model. And sometimes it will disturb the modeling itself. Okay, so yep, please make sure that either you hide all or hide if outside bounding box of active plus buffer zone. Okay, these three, all right, the bottom three are the recommended one. All right, not no action. But of course, it's case by case. All right, so yeah, if the inactive cells are outside the active area, active zone of your model, then you can hide that inactive cells. Okay, but for the time being, we don't need to consider all of that. So let's just click on OK. All right, so here, this is the rescue property importer. We use the file from CMG that already been imported or already been set up. So it helps us a lot like this. So here, let's start here, rescue property and CMG property. You need to match the properties in the rescue file to the CMG property. In this case, from my rescue file, I have 4 properties. The first one is null blocks, second one is pinch out array, and third one is permeability in I direction and porosity. So I only have 4 properties, right? And in the CMG property, I have many, properties, but I need to match between the left one and the right one. But in the file that I open right now, we already have that. We have them already mapped out. Okay, so maybe we can just remove selected mapping. Okay, let's try it by ourselves. Okay, so first I touch null blocks and let's find the same property in the CMG property. Null blocks here. Okay, so null blocks in the rescue file and null blocks in CMG property, and then click on add selected mapping. So we have that, and then the same thing, pinch out array here, pinch out array. Okay, pinch out array and pinch out array. So you can read null blocks imported to null blocks, pinch out array imported to pinch out array. Very easy. Permeability I direction, right? Map and porosity mapped or match with porosity. Okay, so if you have other properties as well, make sure you map or match them with the CMG property. Okay, so far so good. So click on OK. So this is what we have. Beautiful, right? So currently we are looking at the porosity distribution. And the view is IJ two-dimensional RL view. But we can of course change it to 3D view. Okay, I like it better. And you can use this rotate reservoir model if you are interested to know, all right, the entire model. Okay, so far so good. So that's the first thing, the easy thing, that we already imported the rescue file and have it in our builder. Okay, and at the time we can save. So I'm going to save. All right, file and save as. Okay, so this is the directory to which I want to save my file. So click on save here. So this is the directory, and then click on OK. Okay, so far so good. So at least we have saved this model, although we have done pretty much significant advancement in this model, but that's good. We already have the 3D model inside the builder. Okay, now we will define reservoir properties. So let's go first to, you can select this one, and IO control, input and output control. Okay, we can go to title and case ID. Okay, for example, I'm going to call this 3D CCS. Okay. Okay, so in the input output control section, you open the title and case ID, and the window will be shown, and you can input the title. Okay, 3 rows available for you, and you can also make case ID here. Okay, if you want to make several cases, you better use ID there, but in this case we can click on OK. So this is the title, 3D CCS. Okay, and then we can open the specify properties there. Okay, so we have general property specification, and we can expand the window here. Okay, we can find porosity or permeability in J direction. Okay, and permeability in K direction to be equal with permeability in I direction. Okay, so on this one, whole grid, okay, we can make it like this. So permeability in, sorry, Okay, so permeability in J direction will be equal with the permeability in I direction. For the permeability in I direction, we get the distribution, we get the value from the rescue file, right? But we can just make the permeability in J direction equal to the permeability in I direction. And the same thing for permeability in K direction. You can make it edit specification. Yeah, right click, edit specification, and equals I. Click on OK. Okay. And here, right click, edit specification, equals I. Okay. So this will be blanked. The other layer. We have 13 layers here, as you can see, but we apply the equal to the whole grid. So the left one, the other will be blanked. So click on OK. So block corner value calculation, in many cases, you can click on OK. So you should have already permeability in first I direction, this one. Okay, and then yeah, you can choose span here, or maybe you can rotate. And let's check the permeability in J direction. You see, the symbol here is different. Here we have green ball, sort of green ball, right? But on the permeability J and K direction, we have equal symbol there. So yeah, they are exactly the same. Okay. All right. But maybe if you want to have a better, assumption, maybe permeability in K direction should not be equal to the permeability in I and J direction, but maybe a rule of thumb is like 10% of the permeability in I or J direction, because in many natural phenomena, the permeability, horizontal permeability should be greater than the vertical permeability. For vertical permeability will be a fraction of the horizontal permeability. Okay, but in this case, I will follow the guideline or the tutorial from CMG itself. So yes, use the equal sign. And then we can open the rock compressibility here. So you see the symbol here. So it means that we already good in grade and we are already good in array properties. Okay, and then let's go to rock compressibility. Okay, and let's input the rock compressibility C4, pressure dependence of formation porosity, which means the rock compressibility, where the keyword is C4, and let's input the value of 5.8, and then E -7. Okay, and that's the compressibility. And for the reference pressure, PR4, reference pressure for calculating the effect of rock compressibility, we are going to input 11,800 kilopascal. Okay, and then reference temperature, TR4, 25 degrees centigrade. Okay, good. Thermal expansion, we can input the default value. Okay, so click on OK. So rock compressibility already good. All right, and the fluid model for this data set, yeah, we need to address about the fluid properties. So yeah, we will deal with the fluid properties later. And also for the component, I will deal with this one later. And rock fluid interaction, yeah, we will deal with this one also later. Okay, but I want to, in this video, I want to directly go to the wells and recurrent, and let's expand the dates, and then click on that one. I want to add range of date, click on this one. I mean this one, starting from January 1st, 2000, I want to expand it to, surprise, surprise, it should be the year 3000. So, we are playing with the CCS, CO2 injection, CO2 sequestration. It needs relatively, not relatively, absolutely longer period of time of observation. So that's okay. We can play with that 1000, okay, from the starting point of the simulation to the time of completion. So click on OK. So step one, but to make the calculation faster, we just want to do the calculation annually. So step one and then year. Okay. And click on OK. 1000 new dates have been added. Okay, so we will go to the bottom and we will stop at this one. Click on OK there. So, yep, click close. Okay, so the date's already good. We have from the year 2000 down to, surprise, surprise, down to the year 3000, and then we stop there. Okay, let's squeeze it. And then let's go to the wells, double click. Okay, so I want to add injection well. Okay, and I call this one CO2 underscore injector. Okay, and we are going to add a CO2 injector at the center of the reservoir, and we will have constraints, and the constraints, yeah, by the way, here the type is injector, no group. Okay, and in order to keep the new type of constraint has to be set to, of course, later I will put some constraints. And simulation date, yes, the year 2000, January 1st. And then let's go to constraints. Okay, and let's expand the window, can we? Yes. Let's put the constraints. So the first constraint is, click on that one, operate. So for the operate, I'm going to select STG, surface gas rate, maximum. And the maximum value for my surface gas rate, let's say, is the 21,500 meter cube per day. And I'm going to select count repeat. Okay. And add another constraint operate. And now we will play with the bottom hole pressure. I want to inject maximum at that value, at that injection, at that rate, I mean, but the bottom hole pressure maximum, bottom hole injection pressure of 44,500 kilopascal. Again, it's count and repeat. Maximum number of continue repeat allowed, 1. Okay. And then history matching, operate his, okay. And please provide required data, injected fluid properties. Okay, later we will deal with this one. Okay, injected fluid properties. And injected fluid, okay, injected fluid, we are going to select solvent. Okay. And for this one, let's go to this one first. Multiplier, injected fluid, solvent. Yeah, we need to deal with the fluid later. Okay. And constraints. Okay. So far so good. And then later we will multiply. Okay. Click on OK first. All right. Yeah. Yeah, we need to, we need to inject the fluid properties, but later I'm going to deal with the fluid and rock properties later. And then we will go to the well events, double click on that. Okay. And then this one, I want to go to first options. Okay. I want to, yeah, because it's a CO2 sequestration operation, you will not inject the CO2 continuously to the year to 3000, right? So at a certain point in time, you will shut your well in, and then just after the completion of the injection or cessation of the injection, you shut in, and after that you monitor. Or you can monitor anytime, but of course, after you shut in, you will focus on the surveillance or monitoring. Yeah. And let's say I want to shut the injector. I want to shut in the injector after 25 years of injection. Okay. So let's go to after you select options, I'm going to go to the year 2025. Okay. January 1st, 2025. And okay, constraints, status, click on that, and then shut in. Just shut your well in. Okay. Okay. So open again, yeah. Open this well events. The well events window will show up, and then you shut in the well after 25 years of injection in the options tab, and then click on OK. Okay. So first you have the event starting from 2000, but you have another event, and it's at the year 2025. You will just shut your well in. Okay. And then perforation. Let's deal with the perforation. Double click on that and then expand this one. All right. And then we will perforate the well by going to, yeah, of course, the well completion data, perf, the keyword perf, and then the dialog window will show up. And then on the perforation tab here, we will create perforation in the approximate center of the model by adding a row and typing. The perforation, of course, will be conducted in the year 2000, January 1st, 2000. And insert before selected node or insert after selected node. Or you can also use mouse if you want, but it's a controlled tutorial. It's a controlled exercise. So I'm just going to click on this one. Okay, so we will place our perforation, or first we will place our well at approximately the center of the model. So if you look at it, it will be at grid 1925, the I and J direction. But for the Z direction or K direction, it will be started at there. Okay, you can see there. And yeah, I will start the perforation at the layer number 8. Connect to surface, yeah, that's why you can see this window. And FF, formation factor 1. And if you open this one, okay, status open. Expand again. And this is the WI. All right. It is calculated, the length calculated, it's already automatically populated there based on the real condition of the model itself. So, sorry, it should not delete, should select this, insert after selected node, right? And then let's just make it like this. Yeah, it should be connected to 1, okay? And then, sorry, let's put it manually then. And then, yeah, okay. Lastly, the bottom perforation is at this layer number 13. Okay, so if I squeeze it, you can see the well there. And if you go inside the model, the perforation is at this location. Okay, click on apply and then click on OK. Okay, and don't forget to save. Okay, and right now we can stop here, and in the next video we will address the fluid properties and rock properties and the interaction between the rock and fluid properties, as well as of course the properties of the injected fluid, in this case the CO2. Okay, so see you later. Thank you.